So from the laws of motion, force just pull or push of an object, or which changes the position of an object. So it's what are the units of this? The units are what? First, F is equals to m into A, kg meter per second square, gram centimeter per second square. So you know this, 1 Newton is equals to 1 Newton is equals to 10 to the power of 5 9. Okay. So here one more, it's what? kgf. Kgf is what? Kilogram force. It's a kilogram force. For kilogram force, the force with which the earth attracts 1 kg body. The force acts on 1 kg body. 1 kg body towards center of the earth. Towards center of the earth means acted by the earth. So 1 kgf kilogram. So that's what? Kilogram force. Force in Newton. Force in Newton by, it's a G. Like we can go on this. So you know 1 kgf is equals to 9.8 Newton, isn't it? 9.8 Newton. 989. Okay. So you know already the dimensional formula. It's a dimensional formula. So what is the dimensional formula? F is equals to m into A. So dimensional formula of F is equals to dimensional formula of M, dimensional formula of A. Dimensional formula of F is equals to, it's a capital M into L T power minus 2. This will be what? ml T minus 2 is the dimensional formula. So next, what are the fundamental forces in the nature? The fundamental forces in the nature. So it's what? Fundamental forces in the nature. Okay. So the fundamental forces in the nature are very first condition. Yes. First one is about gravitational force. Gravitational force. Second one is about gravitational force. Electromagnetic force. Electromagnetic force. Next one is about nuclear force. Nuclear force. It's a nuclear force. Next one is about, so this nuclear force means what? I can say strong nuclear force. So this is what? Strong nuclear force. Next one is weak nuclear force. Weak nuclear force. So in the order, if you write it, the order of their strengths. Okay, order of strengths. Order of strengths. So what is their order? First one is about gravitational force. It's a weakest force than of all the basic forces in the nature. Next one is about, after this, weak nuclear force. Next one, electromagnetic force. Next one is about strong nuclear force. What is the ratio of their forces? F, strong nuclear force, electromagnetic force, and next one is about weak nuclear force and gravitational force. Strong nuclear force, if I take it as 1 unit, 1 is to 10 to the power of minus 2 is to 10 power minus 7 is to 10 to the power of minus 38 is the order. You can say this is about the basic forces in the nature. Now, so what is the classification of force on the basis of contact? We can write classification of force. Classification of forces on the basis of contact. Basis of their contact is the classification. So for the classification, we can discuss about, there are contact forces, field forces. I can say you very first one, field force. Field force. Field force, it means the force which acts on an object at a distance by interaction. Just interaction, bodies are not in contact. The force which acts on an object. It acts on an object at a distance by the interaction. Yes sir, what are the examples? Where do you see this? So this example for this, you know, this gravitational force. For discussion about this gravitational force, the bodies need not to be in contact. Electromagnetic force. Okay, so like examples for this, what is this? It's a field force. For the second one, when you speak about second one, is that contact force when bodies are in contact. It's a contact force. Okay, contact force. The forces which are transmitted between the bodies. The forces which are transmitted. The forces which are transmitted transmitted between the bodies in contact, when they are in contact. If they are contact means what? It's a short range atomic molecular interaction. It's a short range molecular interaction. Molecular interaction means they are in contact. Sir, can you give the example for contact force? So the best examples, so just which we are using for the problem solving. Normal force is what? It's a N. And second, frictional force, it's a frictional force. It's a small letter F. You know, perpendicular component of a contact force is what? Normal force. Parallel component of contact force is what you say? It's a frictional force. Some standard forces. First one is about weight of a body. It's a weight. Just the weight is what? If you place an object on the horizontal surface, its mass is m. The force which is acted by the gravity on the body is vertically downwards. The force where they are in interaction, this is what? Interaction between these two. So that's what? Contact force is presence. The force experienced by the body due to gravity. This I can say normal reaction acted by the earth on the body is what? Upward. So I can say that force experienced, it's experienced by a body, due to gravity, towards center of the earth. Actually it acts what? Towards center of the earth. So is called what? Weight of the body. So in weight of the body, W is equals to M into G. M stands for mass of body and G stands for acceleration due to gravity. Acceleration due to gravity. The acceleration due to gravity on the earth is what? 9.8 meter per second square. G is equals to 980 centimeter per second square. And next one, if we speak about normal reaction, same the thing which we discussed now. It's a normal. So the weight of the body is what? Where the gravitational force experienced by body due to gravity. The force experienced by the body due to gravity. Normal force, it's a N. Normal force is what? It's a component of contact force. The component of contact force which is perpendicular to the surface, like we can say on this. So it's a component of contact force, which is perpendicular perpendicular to the surface, it's a perpendicular to the surface, is called normal force. It's a normal force. So normal force n is equals to what? M into G. Okay, so this is what, if you speak about normal force, when the block is placed on the horizontal surface like this, between these two contact force is presence. If I draw this individually like a free body diagrams, like this is what body is here, its mass is m, so its weight is acting downwards, and normal reaction acted by the ground on the body is what? N. By the body on the ground is what? N. This is also what? N only. If I take this portion, what is there? N is equals to M into G. Normal reaction, N is equals to mg. Normal, so perpendicular component of contact force is called what you say? Normal reaction. And so just if I talk about this, so if you keep it as an example for this normal reaction or normal force, it changes from when it is placed on the horizontal surface, when it is placed on an inclined plane. If I use an inclined plane, for example, this is what inclination is, the horizontal surface from here, inclined plane which makes an angle theta. Here is a block of mass m. Okay, so then I can go for, this is what, it's a perpendicular bisector to the surface is n, its weight is what? Mg. Okay, this is what? 90. It becomes as what? 90 minus theta. It's a 90 minus theta. So this mg is resolved into the two components like this, resolved into the two components. So it is 90 minus theta, means this will become as what? Theta. So will become as mg cos theta. This is mg sin theta. So normal reaction n is equals to what? Mg cos theta when block is placed on horizontal surface. Okay, so like we can go for, this is what, it's a normal reaction. And next one about for the tension. So when you speak about this tension, okay, just just 1 second. Yes. Okay, so for the normal reaction, like this is the example for it. Next one, if you go on this, another example is taken on the horizontal surface. Okay, so two blocks are in contact. It's what? M1. Next one is about M2. Okay, so external force is acting on this, it's a capital letter F. Okay, so here we can say from this M1 pushes M2 towards right by a force N. M1 pushes M2. Okay, towards right. It's a towards right by a force. Which force is this? It's a N. It's a N. Okay, and M2 pushes M1 backwards. It's a backwards. Okay, so what is this? Backwards means what? Towards left by the force is what? Same. What is this? N. This applies the normal force on this. M2 applies the same normal force but in opposite direction. So clearly I can write this first block this, and second block like M1 and M2 are individually free body diagrams are representing. So M1 acts normal on this. What is this? N. Similarly M2 also acts on this. It's a N only. Okay, this is the actual figure. Just want to discussion about what? Normal reaction. And next one, so when you are drawing this one, we are getting an idea, sir, how should I go for the free body diagram? Okay, FBD. FBD means what? It's a free body diagram. Okay, free body diagram. So what is the free body diagram? Well, just you can check about this free body diagram. Just it's a diagram, the picture which shows the number of forces acting on the body. Okay, so if you draw correct just what free body diagram, so just what we can say on this is what? Number of forces act on a body. So is represented. It's a represented by, so FBD. It's a free body diagram. So free body diagram. So free body diagram, for what steps I need to follow for the problem solving tricks. Okay, first I need to go for step 1. Yes, so how should I go for the free body diagram? I must separate the body from other bodies in contact. First one is about separate the which body free body diagram you want to draw it. The body from other body in contact. Other body in contact is the step 1. Okay, so I'll show the example also. So step 2, draw the weight. Just always draw the weight. Okay, so downwards. It's a downwards, the weight in downward direction. Okay, from next one, it's a mg from the downward direction. From the center you can take it as from center. Okay, so what is the weight? Weight means what? It's a mg. Next one, so identify all contact surfaces. So which are there? How many surfaces are there? So just you can take about step 3, identify. It's identify the number of contact surfaces. Okay, how many are in contact? Next one, step 4. So this is what? Apply. It's a 4th step. Apply. So second law of Okay, second law of motion to get the equation, yes, or to get the result. Motion to get a result is a case. Okay, this is the thing, and I'm going to take about an example for this. How can I draw the free body diagram? Okay,